Okay, guys, correct me if I'm wrong, but I think we got stopped, right? The tangent of alpha minus beta. Okay, and if you remember, let me go back and do this. We're working with these triangles. Remember, this was theta, and this was alpha over here. And you had 13, 12, and 5 here. And we had -4, -3, and 5 here. So we knew that sine was 5/13. And we knew that tangent, and that should be sine of alpha, tangent of beta was 3/4. Okay. And we can't come back and do what's cosine of alpha. Did we write that down somewhere? Yeah, we did. That's just 12/13, right? All right, and then if I wanted to look at sine of beta, okay, that was just going to be a -3. And then the cosine of beta was equal to a -4/5. Okay, it's 3/5, right? So we knew all of those, right? So now I want to take tangent. Well, in those sum and differences formulas that she has all over it, and you have to memorize it, anywhere in there is there a tangent? There is not. So what do you suggest I might do?
Oh wait. Oh, never mind.
I don't want to do that. That's the easy way out. Well, and there is a solution.
Tangent is sine of a cosine.
It is. So let's look at that. So it is sine of a cosine. So if I came back and did this, that would give me, does everybody agree that this is equal to sine of this over cosine of this? Everybody with me? You agree that's an equivalent statement, correct? It gets exciting, okay? All right, didn't we just look back up at the problem up above it? It's off of mine, but it should be on your sheet. Did we already do cosine of? Yeah, and what did we get? 63/65. So I've got that part done. That's a breeze now, right? So all I've got to do is, and you don't have to write this part, but I'm going to, so everybody else see where I am. When I do the differences of sine, it's going to be sine of alpha times cosine of beta minus cosine of alpha sine of beta. All right, and you just told me that we'd already worked this one out. Okay. Well, let's come back and just fill in what we know. Sine of alpha is 5/13. Cosine of beta was a -4/5. And then it's minus, and then we're doing cosine, it was 12/13. Bless you. And sine of beta, which was a -3/5. And that's still all over -63/65. Everybody see where I got all of that? I'm just filling in what I know. All right. Well, bless you. Do is just solve it out. Okay, so stem my page a little bit here. Well, let's just see what that is. That'll give you a -20 over, and you can factor, but I'll show you why I don't want to at this point, because actually when I first did it, I did factor. I'm not doing this. Okay. The reason I don't want to start factor now is seeing my numerator and my denominator. I've got 65. Well, if I do it up in the numerator, I'm going to get the same thing, and that's minus a -36/65. which just gives me a negative 20 plus 36 over 65 over negative 63 over 65. And again, you can skip some of these steps probably a long way. That gives me what? 16 over 65, and that's all over negative 63 over 65. Last step is that's wrong. Where did I get 13 from? Okay, what happens here? Those cancel out, so I'm just left with a negative 16 over 63, right? Questions on that? One thing that's different on that one is I don't have a formula for tangent, but you do know what tangent is equivalent to. Once I set that, so it's pretty easy to work through. Okay. Next page. Getting close. All right, this should look somewhat familiar to you guys, because we've done problems somewhat like this already. First of all, it says determine all the values of x such that your range is from 0 to 2 pi. So I'm doing the whole unit circle this time. I don't have any restrictions. I'm not even just one quadrant here. So they tell me that the sine of 2x is equal to cosine of x. Well, before when we were doing these, if I gave you sine of 2x, you would have been stuck, okay? But now what can I do with sine of 2x? Isn't that a double angle formula? And what did I tell you that, or not I, but what did we tell you that's equal to on your sheet? Go back and look, what is that equal to? Thank you, Josh. Everybody good there? That should be your double angle formula. Okay?
Oh, yeah. Wait.
I mean, we solved it and came up with the same thing. All right. All right, now, I want to get one side equal to 0. So, help me out. What do you want to do? Subtract the cosine of x. So, that's going to give me 2 sine of x minus cosine of x equals 0. And I need an x here. That looks nasty, but anyway, I did. So this is going to be equal to 2 sine of x equals 0, right? No, not. Just right there. Get you up here. That is not. You can't subtract that cosine of x from that, okay? Or this one from this one. But what can I do? I can factor that, okay? I was being facetious this morning. I agree, that's okay. Now what do I do? Set both of those factors equal to what? So that's going to give me cosine of x equals 0, and this gives me 2 sine of x minus 1 equals 0. Now we've done at this point, this is what you have done 1,000 times. So when is cosine of x equal to 0? And I'm using my whole circle here. Three pi over 2. Okay. You didn't give me the 3 pi over 2. Okay, I didn't hear you. Be calm. It's actually pi over 2 and okay. Now this one that through, you're going to get sine of x equals 1/2. Okay. Where is that true? All right, pi over 6 and 5 pi over 6, right? Now, I know you may think have to go back and take all 4 of these, plug them in up here, and tell me if they all work. Then you're going to say sine of 2 times pi over 2 equals cosine true. Don't look at me, do it. It's going to be sine of 2 times pi over 2, which is just winds up being what? Sine of what? Sine of pi. Is sine of pi equal to cosine of pi? Oh, cosine of pi over 2.
Yes.
You agree? You gave me both. Said yes, so it is. What I'm trying to get you're going to see in a minute, I'm going to get some answers that don't work. Keep going. Try 3 pi. I want you to try all 4. They are. Do what? I do. These all work, okay? Now, I didn't have you do that just fine. Plus, this page, or you go to the next page? For me, it's on the next page. That's your next one, right? Is that your next one? Yeah. Okay. You. What should I do here? I don't think you know anything to do. I mean, you can't tell me 1 equals sine x plus cosine x without doing something in this equation. Any ideas? All right, let's do it. How'd you know? Smart, right? She says, Jasmine said to go back, and I think Josh or somebody over there, was it Josh or Joey? Which one of you said square? Huh? All right, so. Okay. I can do that. That's a legal operation. Whatever I do to one side, I do the same to the other. I'm okay. All right. Now, please don't tell me that that right-hand side is sine squared of x minus cosine. What do I have written there?
It's supposed to be a plus.
That is a plus, right?
It's a pi none. Square pi none.
You better have a middle term, right? That's what I'm saying. I thought it was a mistake. So 1 squared, which is 1. So that's going to give me, if you need to, you don't have to do this, but it would always help me. Somebody write that plus sign and don't want to get that one side of it. All right, so that's going to give square root of x, sine of x, and sine cosine of x and sine cosine of x. We plus sine of x, cosine of x. Then what? There you go. Okay, everybody agree?
Yep.
Yeah, what should I do?
So since they're all positive, could you switch your term?
What do you mean switch?
Sine square of x plus cosine square of x. I mean, yeah, sine square plus cosine square of x give you 1.
But I can. I don't have to put them together for it to still equal 1. I can see that, like, I'm fine. If it helps you to put that together, that's fine. But if I see that what Blake's saying, he wants to say like sine squared of x plus cosine. You can do that. That's fine. But you can also go from it. Does everybody understand that this plus this would be what? 1, right? So, all right. So I can go to my next step here. So that would be 1 plus 2 sine x cosine x. Okay. Now what? Subtract 1, which is going to give me the magical 0 that I wanted anyway. going. One more thing, what do I need to do? Do I have two separate factors there? Actually, I have three, but I don't like this. Yeah, no, I do have two separate. Okay. I have 2 sine of x and I have cosine of x, right? So can I set both of those two things equal to 0? I can. So that gives me 2 sine x equals 0, and it gives me cosine x equals 0. Now, well, and this one here I would divide by 2, so you just wind up with sine equals 0 there, right? Tell me where those two things are true. First of all, where is sine of x 0? Pi and 2 pi. Remember, I'm starting at 0, so I could say 0, pi, and 2 pi. Actually, yeah, I know 0 and 2 pi are the same, but how about cosine? Where is it equal to 0? That should be a 2. Now, same thing. You need to go back to the original, okay? And back it up. Once you go back to this one, equals sine x plus cosine of x, and I want you to try each one of these and tell me if they work or not. So you go back to the original. Actually, if we go anywhere, but I'll go back to the original. While you're doing that, let me check and see if it's on anything on something.
Zero. So, you know, that one works. 0 pi, so if you plug 0 pi.
Okay, so back to my original question. Do all of these work? No. Which one does not? Or which ones do not?
3 pi over 2.
That's what I just did. Picked up the wrong one. I'll get it off. So that was 3 pi over 2, right? So that one's gone, right? What else is gone? Yeah, pi is gone also. So my final answer to this one should be 0, 2 pi, and pi over 2. Okay? Then go to your, excuse me?
0 didn't work.
Let's work.
Because your cosine is a positive point and your sine.
Okay, you try that one on your own.
Does that mean that
Pi doesn't work because your cosine.
yeah, okay, so there's so 0 works, pi does 2 work, and then what works?
2 pi.
Yes.
Just zero, two targets.
I know they're at the same place on your stuff, but you've got to, it's
Time
a,
that you have zero. Yeah, the opening there's some.
Then what's zero plus negative one?
because you want them to equal 1, right? And that equals negative. Okay, so everybody should be doing this one here, right? Right? Doing this one. What do you got to do there? Take a stab at that one.
It's one of those.
Yes, it is one of those. I don't ever want to work with those cosine and sine in the same equation. So if I can change something, that's what I think I would do. I take it back. I may want to work with cosine if I can apply the double angle or half angle or whatever to that. I can't apply that to that. Well, there should be something up there you see that you can't change. You can't. Yes. No, you can't. With one minus. No, just leave the 2 and it'd be 1 minus cosine, I mean, sine squared. Then you can distribute that. Okay, just to make sure everybody's got the step before you keep going, you should change this to 2 times 1 minus sine squared of x minus 1 equals 0. Now keep going, distribute that, and you should see automatically, once you get your like terms together, what you've got to do. You've done problems like this before.
I'll tell you one thing, I was looking out. Because I kept getting so many never happened on at least one of them. Like when you get to the test, and we were first doing these, you know, like some of these can't happen.
Yeah.
I was sitting there getting a lot that happens, and I was like, oh, I screwed this up really bad. But I didn't. I was getting
Josh, not over, but did you say something about square root? Oh, I thought I would say something about square root. So you shouldn't have to take a square root of anything on this problem. I'm about to do it again. Get this out of my hand. Actually, yeah. All right, everybody get to that point? From here to here, all I did was distribute. And then I just reversed these. I kept my sign so I can do that, okay? Even though don't freak out since your square terms on the end here. Can I factor this? I can, so factor it.
So like, I wish you had in other, like the other order. And then like I had the negative 2, so I'm gonna do that, like what's it called, 101?
Yes.
I think it'll work out. So
I put it, because I just don't,
Yeah.
like, I have to have it at the front.
that's fine. I think it'll work out.
I put it in the, like, right order to the negative 5, and I just factored out a negative.
That's what you was actually doing.
So I did.
Okay. It shouldn't matter because that -1, when you divide it on, you got 0 on the other side. I'm just gonna leave it the way it is. You can probably go either way.
Wait, so basically this
All right, when you factor that, if you left it in this order, this is what you should have, but you gotta get your signs there, okay? So this should be plus here and minus, because I want a minus in the middle, okay? And at this point, I've got two factors, I can set them equal. So this is gonna be 1 plus sine of x. Equals, it's gonna give me sine of x equals a -1, okay? This is minus 2 sine of x equals the -2 sine of x equals a -1. So that gives me sine of x is equal to 1/2. Now my question to you, Chloe,
I didn't get that.
then we got a problem. Okay,
I got them all.
hold on. Let's see what we got. First of all, what is sine of -1? I mean, when is sine of x equal to -1? All right, it's 3 pi over 2, right? All right, and when is sine equal to 1/2?
5 or 6.
And,
5.
all right. What did you get when you do all the racing?
I got them just opposite. Like I got sine of x equals 1, and then
Yeah, but I'm saying where you're fine. It may still work out. I don't know. Hold on. We'll come back and look at
yeah, I
it.
didn't get that.
We'll come back and look at it. Okay. So again, I got to check all these. Do these work? Go back to your original.
How squared, or would it really make a difference?
How would you do cosine squared? I don't mean that to sound facetious. Okay.
That's an excellent question.
All right. Wouldn't I? For that first one, I use 3 pi over 2. Square that. What is that?
Oh, so that's how you. Gotcha.
Whoa, stop. Don't let, just know what I just said. What you need to do is put that in, okay, and you take the cosine of 3/2. 3 pi over square that. Sorry, I'm not paying attention. Everybody understand what I'm saying? Blake's question was, how would you do that how would you handle that cosine squared term? Well, all I got to do, and I'm checking all these answers, so I can put 3 pi over 2 in there, okay, square it, then multiply that by 2, and then subtract sine of 3 pi over 2 minus 1, and if it all equals 0, I'm okay. Does that work?
So just making sure you find what cosine equals at 3 pi over 2.
Yes.
Square that number.
Yes.
And
And then multiply by 2. Okay?
Yeah.
Go ahead and apply what you need, first. Okay? So I think if you apply all of these, you should find that they all work. Okay? Does everybody understand what I said to apply those? Ben, you follow me? So what do we do? Yeah, how did I say to do it? If I took that 3 pi over 2, how would I apply it back up in that equation? All right, so what am I going to do?
Plug in 2 cosine squared. You can plug it in 3 pi.
Okay, but how would I handle that square term?
I don't know.
I just went over, that's why I'm picking on you, but you got to focus here, okay? You take that 3 pi over 2 that you're substituting, find the cosine of that, whatever that is, and then square it, okay? And then multiply that times 2. Okay, and then that's the way you use all of them. You should find that they all work, okay? All right, guys, we have 2 more problems. Let's get them done. All right, so you do the next one. I'm working with tangents, so you should automatically know you've got to do something. Well, not actually you don't. Let me back up. Any ideas just looking at that right now? What is the first thing I told you to always do when you're looking at an equation? If you can do what? Yeah, GCF. Do you have one here? What is it? What is my GCF here? Then I'm left with what? Tangent square root of x minus 3. Do I need to keep going? Or can I set both those equal to 0 now? Keep and go from that point on. All right, so you're saying I can do it. All right, let's see if we can. First of all, the first one's easy. It's just tan of x is equal to 0. I'll let you tell me what that is. That's tan squared of x minus 3 equals 0. I would have to add a 3, right? I want that tan. Take the square root of both sides. That's going to give me tangent of plus or minus square root of that. Possible?
Yeah.
All right, so go back. Tell me where tangent of x is equal to 0. And what? You said it, 0 pi. Okay. Where is tangent of x equal to either plus or minus? Why do I use both of them? Because I was working with the whole unit circle. Remember, that goes back to my first, what they told me my conditions were. So you should get pi, 2 pi over 3, 4 pi over 3, 5 pi over 3. Check them.
Tangent's
Oh.
y divided by x, right?
Huh?
Tangent's y divided by x, right?
It's y divided by x.
Yeah. Tangent would be like side of the other, that's how you apply, right?
Yeah. Okay. Yes. But just plug, you don't have to worry about it.
Yeah,
Just plug it in. Because you got that sheet that we did. Okay, remember the sheet we did? So go back up. You plug 0 in. Well, 0 squared cubed is minus 3 times tangent of 0. Well, what is tangent at 0? Look on your sheet. What is tangent at 0? At angle 0, what is tangent? It is 0. So I'm just doing 0 minus 0 equals, that's going to happen to be true. Check the other 6 more. 6 more to do. And that'll take about a second each. If you do. Like, you see what I'm doing?
Yeah, I got it. It's because
When I said 0, it's the angle is 0. X is 0. So I'm looking at the angle.
If it equals 0, tangent equals 0, and 2 pi, would that mean all of them would work or not? Like, what would be the difference?
That's my question. Do they work? I don't mean that to
I
be-
don't know how I would
Well,
do it.
All right, go back. I want you to put this in there. First of all, tell me what tangent of pi is. Don't worry about each one. You told me that. You're right, they're all going to work, but is this 0? Okay, so that still gives me 0 all the way across. Right, they're all the 0, but I need to check to make sure they are. Don't let that throw you off.
They would basically be the same.
Well, these 3, they all work out to be 0s. Okay, how about here across? What's tangent at pi over 3? It's the square root of 3, right? All right, and then when you cube that, what's that going to be? No, now we're getting fancy here. But it's not that hard. What is square root of 3? No, it's not.
Well, that's an excellent question.
Okay.
There's a double. That's weird.
Do you agree that that's square root of 3 cubed, right? Well, square root of 3 times square root of 3 is 3, right? I do believe that's what it is. Okay, and what did you just tell me tangent of 3 was? I mean, x pi over 3 was? It's square root of 3, right? When I plug in pi over 3 to this part right here. Isn't that going to be tangent pi over 3 is square root of 3, or root of 3, as you guys say. So that, you told me that the cube root is 3 times square root of 3, and that's going to be minus 3 times square root of 3. I do believe that's 0 too, right? On the same time, I think they all work, okay? Because I feel like I'm the only one doing it. Okay, but they do work. Okay, but I'm telling you, because I proved it, some of these did not work. Some other problems. You have to check them to make sure. Okay? Last problem. And you really need to focus on this one. All right, so it tells you to, Sarah and Jared, it tells you to determine the intervals containing range from 0 to 2 pi, where the function is positive, and the intervals where the function is negative. Okay? So we're going to have to work this out, and then we're going to have to find out what range are they positive, is this function positive, and what range is it negative. So this is going to take some time here. Not time, but it's going to take, we've got several things we need to go through. Okay. What do you know that cosine of 2x is equal to?
Cosine squared of x minus sine squared of x. So you could put cosine squared of x.
Hold on, please tell me.
You don't look at your test. I mean,
I really, you tell me this.
such a choice. She said it was as much her errors as it was our errors. Well, we had part of it right, but then she said she should have realized that we were not this year. They got one. She's supposed to send you a revised contract.
I didn't tell you what happened. I thought we lost that, but I didn't expect it to. Some of these, I had a horrible night. And my wife has too.
I told her that there was a good possibility that I would not have a job.
I would get that job, I think we'd be dead.
So she's supposed to send you a revised.
Okay, thank you so much. All right, now, so, I'm sorry, Josh, I didn't mean to George, I didn't mean to interrupt you. Okay, so you're right, that is equal to that, okay? Let's get everything in terms of cosine here, okay? So, if I went on with that, I'm just working with this part here. That's going to be square root of x. And what can I change that to in terms of cosine? Okay, good. Well, let's distribute that. Okay, and then the last thing I can say, that's just going to be what? 2 cosine squared of x minus 1. I just want to do that part right now. I'm going to come back and put that in, okay?
Where did they get that formula from?
This is your double angle formula. I'm just working with this part, okay? If you go back to your double angle formulas, like Josh told me, it's cosine squared of x minus sine squared of x. Well, at this point, I'm working with 2 different trig functions. I want to get back to one. But since this was cosine over here, let's get it in terms of cosine there. So I've got that. So now, going back, Sarah, to answer your question, then I'm going to say this is 2 cosine square root of x minus 1 plus cosine of x. Okay? Solve that cosine of 2x first. Does everybody understand what I did? Separated this out and worked it through first. Okay? I'm just going to change the order here. So that's 2 cosine square root of x plus cosine of x. And that should be minus 1, right? What can I do to that? I can factor, so you factor, okay? Now that one should be in the form you want. Remind me when we get to go back and check that over, if you fact that, it may work, I don't know, I need to check this out. Excuse me? Jerry, that's what I did here. I took that part and just worked through here. Okay, that's good. All right, that's fine. You good?
Do you feel better?
I laid awake all night long, guys. That was, we're still in the world when I got an email last night saying, we don't need to show that you have a contract. I did it like 9 o'clock. It's been a long night. But it's all done. I need to let my wife know. It should be fun too. All right, so when you come up with okay, does everybody understand how I got from this whole thing down to here? Again, I just took this out, worked with it, put it back in, and then you can fact it. Okay. Well, let's finish it up. We're almost done. So at this point, I can set both these factors equal to 0, right?
Yes, sir.
All right, so that's going to be 2 cosine of x equals 1. So cosine of x is equal to 1/2, right? Okay, this here is just cosine of x is equal to a -1. Okay, tell me where those are true. Let's start with cosine of x. Where is cosine of x equal to 1/2? All right, it's pi over 3 and 5 pi over 3. Okay, where is cosine of -1? Just at pi. Okay. Well, I found those, but I'm not done with my problem. Okay, what did it, go back up to the top of the page, what did it want me to do? To tell where the function is what? Positive, and where intervals where it's negative. So I got to figure out where this function is going to be with these answers. Where is it going to be positive? Where is it going to be negative? So this is where I really need you to pay attention. Do this in green. I'll come back down a little bit so I can see my answers again. All right, so those are the 3 things I'm working with, okay? I'm going to put number line up here, okay? I'm going to go, this goes from 0 to pi over 3. That's the first range, okay? Then I want to go to pi. Then I want to go to 5 pi over 3. Okay, and then I can just go out, you know, your whole range is 2 pi, but okay. Well, why did I pick those numbers? Well, that's what I've got here. So, you know, your period is 2 pi, all right, or your interval that they gave you is 2 pi. So I can start with 0. I had pi over 3. I had pi over 3. I don't know if you're there. All right, now I want to know where. Let's go back to these 2 factors I found. Cosine of x minus 1 and cosine of x plus 1. Okay? Drawing a little bit so that'll come down here too. Okay, give me a number in terms of pi. Give me something that's between 0 and pi to work with on my unit circle. That's okay. So you tell me if I plug pi over 6 into 2 cosine pi minus 1. Tell me if it's positive or negative. First of all, what is cosine at pi over 6?
3 over
root 3 over 2. When I multiply that times 2, that gives me what? Root 3, right? Just root 3, right? Minus 1. Is that a positive or a negative number? Root, if you take the square root of 3, it's greater than 1, right? I don't care exactly what it is, but does everybody understand that when I plug that in, that positive number, right? Everybody with me? Okay? We'll do the same thing for this one. So I get cosine of root 3 plus 1. What does that give me? Well, that's square root of 3 plus 1. That is a positive number again, right? So, now, why am I doing this? Yeah, good job. I want to know when I multiply these two things together, if they're positive, then that means that's where my function is positive. Positive times a positive, what do I get? I get a positive, okay? All right. You finish it. Take these three intervals. I want to go between here, so pick a number. Between here, pick a number. Between here, pick a number. And I want to know what each one of these is going to be. The main thing I want to see is where they are down at the bottom, so they can answer it. Then we got to put it in analogy. Why? I want to email my wife.
Oh, we'll see. Insert power to that when you make power to the shopping power to you have 0.
I'm not worried about
the first thing was positive.
don't change it.
I'm gonna lost it.
They don't know who it has. Have two. Two power. So 2 power 3, 2 power 1 half. Does that make it -2?
Alright, which one did you
I
pick?
just don't understand.
Which one did you pick?
2 power 3.
Pick 2 powers.
I don't care what to do.
Which would be negative 2.
So it's just negative 1 5 1.
Which is it's gonna be the same thing. It's gonna be the same thing.
Cosine of 2 power 3.
Which is the same number.
That'd be a positive. That's the
Okay, what'd you pick between pi over 3 and pi? Okay, pi over 2. That works. So when I plug it into the first equation, do I get a positive or negative?
Negative.
I get a negative. When I plug in the second one, what do I get? Positive. So that means that the function there is going to be negative. Can't do that, can I? Okay. How about from, where did that come from? How about from pi to 5 pi over 3? What are you going to pick there? Give me a number. What? 3 pi over 2? Is that what you said? Okay. All right, so Jasmine, not to pick on you, but since you picked that one, what'd you get when you plugged it into this first equation? Positive or negative? It's positive. How about the second one? What'd you get? It's also positive. So that means that my in that range. Last one. What did you pick from pi over 3, 5 pi over 3 to 2 pi?
3 pi over 2 is 0. Right? So 2 times 0 would be.
No, I was just doing, that's picking up, but I was just writing whatever you wrote there. Actually, it isn't. It should be, the first one is negative, right?
I'm sorry, I wouldn't mean to like.
And this one's positive, right? Which means this should be negative. We're right now? Okay, last one. What'd you pick for between 5 pi over 3 and 2 pi? That's fine. Either one will work. So let's just go 11 pi over 6. You should find that both of these are positive. Okay, but I am still not done. Okay? If I go back to look at my original question, it wanted to know where's the function positive, or it says determine the intervals where it's positive and where it's negative. So that means you got to put it in interval notation. All right, which takes you back a little ways. Well, let's do that real quickly. Okay? Looking at that, let's just do the positive side first. All right? On what intervals do I have that is positive? It's 0 to what? To pi over 3. Okay? That's not inclusive. Okay? So you have just parentheses. What's my other interval? To 2 pi. Good. It's 5 pi over 3. You're right. To 2 pi, which is my then, right? Ah. Okay, so that's where it's positive. Where is it going to be negative? So it's going to be negative from, and I blanked it out, should be from pi over 3 to pi, right? And from where? Pi to 5 pi over 3.
So why can't you just do like, why just include?
I'm sorry, Kylie, I don't know what you're
Like, why can't you just do pi over 3 to 5 pi over 3?
Well, what?
Like the negative, why can't you have that difference here in notation? Like why is pi not included?
You're right, I could that one. I could just,
So I could write
this
pi
could
over
just
3.
be, yeah, it
Yeah, I was
could
just
be, yeah.
thinking
You could write it either way. Yeah, you're right. I'm sorry.
But when that, I'm not trying to like.
Hold on. Well, I'll go ahead with your question.
But when that basically said that pi is included.
It would if I don't put it in, if I put that in there. So why is pi not included?
You get a 0. Because the pi, your costine's -1. And so you're telling me -1 plus 1 is 0. It's not, technically not positive or negative. It's not specified.
I mean, that again, so it can be.
So if you were to plug in pi and just that, like for cosine plus 1, we get pi is -1. And -1 is 1 and 0. And so,
Which is negative positive on there. So that is true. Hey, guys, listen. You wrote this in, you would get 0, I think, for your function. Right? So that's why pi is not included. That's why I have to write it like this. I can't go all the way from here to here. Because I think if I use pi, that's going to give me 0 for my function. Well, that's neither positive nor negative. So that's why it's not inclusive. Thank you. Good call. We are finished with this section, believe it or not. Here's your homework, and you got about 15 minutes. I would suggest you get started on it. Save you some time. It is on page 235 in your books, and you're going to do number 5, 13, 14, 35, 38, 39, 41, 42, 4. If you start now, you can probably get about 4 of those done.
Alright. That's gonna be like.
Come on. Hey, this is all been something I've had to go back and do.
Okay, Holly. Speak louder.
She did not. I mean, I'll take the question. I'll have her address that on. She did not, but that doesn't mean that it's, I'm not saying she's wrong, I'm just saying that's a good question. And again, using your time wisely, should be, you should know how to do that now. If you know it's tangent, you need to break that 5, 5, or 12 into something you can deal with.
No.
I guess the bathroom.
Dylan's left it well.